In this video, we're going to work in section P5, and this section is all about factoring. So we're going to start by reviewing factoring out a GCF. GCF stands for greatest common factor. And to factor it out, first we need to figure out what it is. So the first step is to determine the greatest common factor of all terms. For the numbers, or the coefficients, we find the largest factor that divides into each number evenly. And for the variables, we include all variables that are in common to every term raised to the smallest exponent. Then when we're factoring out the GCF, we think backwards distributive property. Whenever you have a factoring problem, you always want to look for a GCF first and factor it out if there is one. That can make the rest of the problem a lot easier if you get that GCF out first. So looking at example 1, the first problem is asking us to factor 18x to the third plus 27x squared. So first I need to think about what number both 18 and 27 can be divided by, and what is the largest number that both 18 and 27 can be divided by. Well, I know that 18 is equal to 9 times 2, and I know that 27 is equal to 9 times 3. So 9 is going to be the GCF because 2 and 3 don't have any other factors in common. So I could also factor out a 3. I know that both 18 and 27 can be divided by 3, but that's not the greatest factor that they can be divided by, and so that would give me a wrong answer. So 9 is what I'm going to want to do. And then for the variables, I see that both terms have x, and so that tells me there's going to be some x's in the GCF. And I want to take the smallest exponent. So we have x to the third and x squared. That tells me that I can take out x squared because 2 is smaller than 3. Now I'm going to set up my parentheses. I have 2 terms in my original polynomial, and so I'm going to have 2 terms separated by a plus sign in my answer. Now the question is, what do I multiply by 9x squared to get 18x to the third? Well, we can take it one step at a time. What do we multiply by 9 to get 18? Well, we need to multiply by 2. And then what do we multiply by x squared to get x to the third? Well, we need to multiply by 1 more x. X times x times x is x to the third, and so I need to have 2x for my first term. When I distribute this back out, I would get 18x to the third. So I can always check factoring out the GCF problem by distributing. Now for the second term, what do I multiply by 9x squared to get 27x squared? 9 times what is 27? Well, that would be 9 times 3. And since I have x squared in both, I don't need to multiply by any more x's because 3 times 9x squared is just going to be 27x squared. So that would be my answer. Part B is a little bit different. My GCF here is not a single variable or number, it's actually this set of parentheses. So the x plus 3, that binomial, is the GCF. That's the factor that they have in common. And so to factor that out, I would put that x plus 3 on the outside. I'm going to keep it in the parentheses. And then I'm going to have a second set of parentheses that includes this and this, x squared and plus 5. So I sometimes call those the leftovers. If I think about distributing this x plus 3, you kind of have to think of that as one kind of whole thing, one chunk. X plus 3 times x squared, that gives me this first piece here, and then x plus 3 times 5, that would give me this second piece. And so that's the answer for part B. So next you should look at checkpoint number 1. Do this in your notes, check your answer, and then move on with the video. The next type of factoring that we're going to look at is factoring by grouping. And we use grouping if there are 4 terms and there's no GCF in common in all 4 terms. Or if there is, we can factor that out first. So if we have 4 terms, we split the polynomial into two groups of two and factor the GCF out of each. The set of parentheses that results should be the same, and then we can factor that out similarly to how we just did. So, looking at example 2 from the textbook, we're factoring x to the third plus 4x squared plus 3x plus 12. So what we're going to do is split this into two groups, just like that, and look at the first two terms and then the second two terms. So if I'm factoring out the GCF of just the first two terms, that GCF would be x squared. And then that's going to leave me a set of parentheses that's going to be x, because x squared times x gives me x to the third, plus 4. I need to multiply by 4 to get 4x squared for the second term. Then I forget about that and look at the last two terms. Now in this pair, my GCF would be 3. And what's going to be left in the parentheses is x plus 4. So what should always happen here is that you should get the same thing when you factor the GCF out of the first pair and the second pair. You should get the same thing in parentheses. And so that's going to be one factor. And then these pieces in the front are going to make up the other factor. So my other factor here would be x squared plus 3. So next you should look at checkpoint number 2, and I'm going to give you a little bit of a hint here. This one is a little bit harder because there are minus signs. And when I'm factoring out my second pair, I'm going to factor out -2. And that's going to leave me a set of parentheses of x plus 5. Distributing a -2 here would give me -2x and -10. So finish up this problem, check your answer, and then move on with the rest of the video. Our last topic for this video is factoring trinomials in the form x squared plus bx plus c. So we do not have a number in front of x squared. We're looking for two numbers that multiply to c and add to b. C is the number that's by itself, and b is the coefficient of x. The factor trinomial will be in the form. So we're going to have two binomials, two terms, two sets of parentheses, x plus or minus a number and x plus or minus a number. And we can always check these using FOIL. So I'm going to set this up with my two sets of parentheses. And now I'm looking for two numbers that multiply to 8 and add to 6. So sometimes people like to make a list of the numbers and then they can have a better visual and just kind of go through and see which pair works out. So numbers that multiply to 8, that could be 4 times 2, or it could be 8 times 1. There aren't a whole lot of options there, which makes it easier. And then look at, okay, which pair of these two numbers adds to 6? Well, that would be 4 and 2. So this is x plus 4 and x plus 2. And then if I want to check that using FOIL, first, outside, inside, and last. When I add up those middle two terms, I get 6x, x squared plus 6x plus 8. That's what I had originally. So next you should do checkpoint problem number 3. Do this in your notes, check your answer, and then move on with the video. And lastly, we're going to look at example 4. So example 4 is the same idea, but it's a little bit different because now I have negative signs. So now my numbers are multiplying to -18, which means I need to have one positive and one negative number. If you're multiplying to a negative number, the only way that can happen is if one number is positive and one number is negative. So for this, possible numbers that multiply to 18 would be 6 and 3, 9 and 2, or 18 and 1. Now, instead of looking for the pair that adds to 3, keeping in mind that one's positive and one's negative, another way to think about it is that they're going to subtract to 3. Or if I'm adding a positive and a negative number, that's going to equal positive 3. So the pair that would subtract to 3 would be this first pair, 6 and 3. So I'm going to set up my parentheses here. And then in terms of the signs, I want them to add to plus 3. So I need to have plus 6 and minus 3. If I did the plus sign on the 3 and the minus sign on the 6, that would give me negative 3. So you need to make sure you get the signs right, and as always, it's a good idea to check using FOIL. You can even just do FOIL in your head, you don't have to write it out, but you should always think about, is this multiplying out using FOIL to get me back to what I originally started with? And in this case, it does, so that's good. So next you should try checkpoint problem number 4. Do this in your notes, check your answer, and then you can do the homework for this section.